Hi, welcome to the final notes of our solids unit. We are going to be talking about spheres, composite figures, and revolving solids today. So we got a couple of formulas for you to memorize. With spheres, there are only two formulas. There's the formula for surface area, which is 4 pi r squared, and the formula for volume, which is 4/3 pi r cubed. Obviously, there's no lateral surface area formula because a sphere just has one surface. All right, so if we want to find the surface area for a sphere with a radius of 7, we just plug it into our formula, 4 pi, 7 squared, which gets me 196 pi, and the units are centimeters squared. Straightforward. Just memorize the formulas. All right, so here we're given the surface area of a sphere, and we need to find the diameter and the volume. So we're going to need to begin by finding the radius. So surface area equals 4 pi r squared is my formula I'm going to begin with. So 110.25 pi. For some reason, students seem to glance over anything that contains pi. Make sure you include the pi here or it's going to mess up your answer. Equals 4 pi r squared. Divide both sides by 4 pi to get rid of the stuff in front of r. So we get r squared. Here my pi's cancel. 110.25 divided by 4 equals 27.5625. Take the square root of both sides to find out what the radius is, and I find out that my radius is 5.25 feet. All right, so that means my diameter is twice that, so my diameter is 10.5 feet, and my volume equals 4/3 pi r cubed. So I substitute in my radius, 5.25 cubed, and I find out that my volume is 192.9375 pi, and that would be feet cubed. I could also do this in fraction form, even though this decimal terminates, which means I'm not rounding, but I could put it in fraction form, and that would give me 3087/16 pi feet cubed. So either one of these two is perfectly acceptable. All right, I would like you to find the surface area and volume of a sphere with a radius of 3 millimeters and come back and check your answer when you're done. So hit pause now. So for both of them, you should have gotten 36 pi, except for surface area, it should be millimeters squared, and for volume, it should be millimeters cubed. Okay, let's take a minute here to talk about composite solids. So a composite solid is simply made up of two or more of the solids that we've talked about thus far in our unit. So for example, this here is a cylinder with half a sphere hollowed out of it. So maybe like one of those metal drums that you see in the Caribbean, something like that, except it's a little more spherical than that would be. So maybe it's a gallon of ice cream with a perfect scoop of Rocky Road carved out of it, if you are feeling particularly imaginative. All right, so we need to kind of come up with a process for this. So basically, if I were to find the volume of the solid, because it is a cylinder, I'm going to find the volume of the cylinder, and then it's got a half sphere carved out of it, so I'm going to subtract half the volume of my sphere. So I just basically need to know what these two things are, substitute them back in, and I am good to go. So my volume of my cylinder is going to be area of the base times the height, so pi r squared h. So the volume of the cylinder is going to be pi times my radius, which is 3 squared, times the height of the cylinder, which is 5, which means that I get 45 pi, and that would be in inches cubed. All right, and then so for my volume of the sphere, that would be 4/3 pi r cubed. So I get 4/3 pi, my radius is 3 cubed, and that gets me 36 pi inches cubed. So when I substitute it back into my problem, I take 45 pi and I subtract 1/2 of 36 pi, and let's see, 45 minus 18 is 27. Does that seem reasonable? So 27 pi inches cubed is my answer. All right, here we have a composite solid. This time we have a cylinder and we have a half sphere added to it. And they want us to find the volume. So our process would probably look something like this. The volume of the cylinder plus 1/2 the volume of the sphere. All right, so it asks for answers in exact, which means that we're going to have pi in our answer, and approximate, which means we are going to round. And because we're not told specifically to use 3.14, we're going to go ahead and use our pi button. And when I say we, what I mean is you, because I would like you to answer this problem for the notes check. All right, moving on to our final topic of this section of notes, and that is rotating solids. And all rotating solids means is we take some kind of polygon on a coordinate plane and we rotate it about either the x or the y axis. And then we have to figure out what kind of solid that would make in terms of its rotation. So we take a 2D figure, we make it 3D by rotating it. And since we're talking about rotating means to move in a circle, then we're always going to have a circular base. So basically the question is, do I have a cylinder or do I have a cone? Well, if I begin with a rectangle, then when I rotate it, it becomes a cylinder because I have the top and the bottom both rotate, becoming circular bases. Okay, and so here we have a cylinder, and this point right here is the point 3,4, which means this is 3 and this is 4, because this is my origin, 0, 0. So basically that means that 3 is my radius and 4 is my height. So to find the surface area and volume, my surface area is pi r squared, 2 pi r squared plus 2 pi r h is my surface area. So I plug in 2 pi 3 squared plus 2 pi 3 4, and I get, what is this, 18 pi plus 12, 24 pi, which means that I get 42 pi units squared. My volume is going to be area of the base, so pi r squared times the height, so it's going to be pi 3 squared times 4, which means that I get 9 times 4, so 36 pi units cubed. All right, and that's how we work rotating solids. Okay, here I have a triangle that I'm rotating about the given vertical line. So I'm rotating it again about the y-axis. And they want to know what shape is formed, and then they want you to find the surface area and volume of that shape. So this time, this point stays put. This section rotates around. So I want you to tell me the shape, and then give me the surface area and the volume for that shape. And I want you to do that in the notes check. Check. All right, moving on. Okay, so here, this sort of gives away the previous question, but anyway, nonetheless, we've got a triangle rotating about the x-axis, so rotating about this axis, and then rotating about the y-axis, and we need to figure out which one has the greater volume. Well, if I rotate this triangle about the x-axis, then my radius becomes this one, because this is the part that's rotating. So my radius is 4, and my height is going to be 3. If I rotate about the y-axis, then my radius is 3, and my height is 4. So without using your calculator, which cone has the greater volume? I want you to explain this, so not just answer it, but to explain it in the notes check. All right, this concludes this unit's notes. Please be sure to go on and do the notes check. If you have any questions about anything we've covered today, because I know we covered a wide variety of topics, and sort of went through them fairly quickly. So if you have any questions, please be sure to ask in class. Thanks.